Okay, so in this entire like summer cohort, I will be teaching you all Python and I will shift quickly to ML. So my main goal is not to like teach you like full theoretical Python, but to like actually give you the best and important concepts which you will be using in real life and day-to-day situations. And like I will also teach you important libraries which you will be constantly using if you are working in AI, ML, data science. That's it. So before we start programming, I will just give a brief description about Python. So wait. So Python, as you can see, it is a high-level interpreted and multi-useful programming language. So now you might be asking like what is a high-level programming language? So high-level programming languages are certain languages that are like closer to human language and you can understand them properly instead of like having to see and check every comma, every semicolon. Like, the high level languages are much easier to understand and much readable than low level languages. As you can see, the low level language looks pretty much weird. Even I can understand this because I'm not familiar with low level languages. I don't do low level language at all. But you can see the high level language, the code is very much simple. Like ignore the gray text. Like check it. Like a is equal to 5, b is equal to integer input, enter a number, if blah 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 blah, print this. That's it. And in the low level language, you can see like dot global at 42 integer 32. Here you also have to like give the data in the low level language, but in high level language, the data is automatically interpreted. Another thing is that high level languages are easily understood by compute I mean like are not easily understood by computers and need extra time. But like low level languages are easily like understood by computers and can like directly touch the hardware. So this this thing which you are right now seeing, this thing is good, but the thing is that it does not like fully touch the hardware, and like you still like have to do some explicit coding to like touch the hardware. But here the code isn't readable, but the best part is that it can like touch your hardware and you can like modify and manipulate it as much as you want. That's the best thing about low level language. But forget a low level language because we will be focusing on Python, which is a high level language known for its clear syntax. So let me just show you one thing. So syntax, if I go here and like type what's a syntax in programming language, you will see like it's the specific set of rules that dictate how symbols, keywords, and characters must be structured to write a valid program. And where was it? The presentation. Okay. And here you can see that the syntax of Python is very much simple. Let me just write one code like x is equal to, let's say for example 5, y is equal to, let's say 10, and area is equal to x multiplied by y, and perimeter is equal to, PM means perimeter. Okay, so perimeter, let's say uh, 2 multiplied by x plus y, and let's say print. Yeah. Oh, I forgot to connect it with the server, so let me just connect. So it take a bit of time, like some 30 seconds or so. So let me just type the code in the meantime. Print perimeter. So as you can see, the definition of syntax is that it's a specific set of rules in which symbols, keywords, and characters must be structured to write a valid program. So as you can see that this is the entire syntax. Okay. Syntax basically means the structure in which the code is written so that it can be executed like in a proper manner without errors. So as you can see, I assign that x is equal to 5 and y is equal to 10, and then I show like area is equal to length into breadth, or x into y, perimeter is equal to 2 multiplied by length plus breadth. That's it. And now to show the area and perimeter, I just do this: print area, print perimeter, and let me just run it. That's it. See, 50, 30. That's how simple the Python syntax is. Now, let me show you here. Okay, so In programming, whenever you do programming, there are two types of main things which you have to keep in mind. Number one is logic. Logic is nothing but the way in which you understand how the data flows. Like, for example, how mathematically and, computationally the code works in a sequential way so that you know what function has what thing to do, which data structure has the best, speed, and which can like be executed fast, which can be mutable, etc., etc. That's the entire thing of logic. Logic include like math, a bit of math, a bit of computation, computation. Uh, just ignore my very thick handwriting because just ignore it. I hope you can understand this. So it requires math, computation, and a bit of structural understanding. That's the most important thing. Structural understanding. Understanding. That's it. Now the now logic is something that most of the programmers already have, but the main thing that programmers struggle is with syntax, and that's a real reason because the same logic. Let's say for example, you want to like show the number 2. It can be written as is equal to 1 plus 1. That's one logic because you have added a plus, and plus is a logic. Like you that's a structured thing. You cannot like 2 is not equal to like 1 minus 1 or 1 plus 3 or any other number. It's 1 plus 1. Or you can also, it is also equal to, let's say, 2 plus 0. That's also correct. And it is also equal to, let's say for example, 3 minus 1. That's also correct. This is the logic. But the thing is that in Python, C++, let's say in Python and in C++, in C++, or in Java or in any other programming language, you don't write like this. You write in a specific structure so that the code can be properly executed. If like the same thing which works in Python, if you know 2 plus 2 very well, but if you cannot show it in Python, then there will be an error. And let's suppose you know the Python code very well, you know the Python syntax very well, and you also know the logic of programming very well. But if you don't know the syntax of C++, then there will also be an error. There will 100% an error. You cannot like type the syntax or a code that is used in Python exactly in C++. And in Java also there will be an error if you like try to type your own logic. So most programmers or YouTube channels try to focus on logic. But the thing is that logic can be easily developed. Logic, because if you have a strong brain in math and logical things like physics and etc., then logic won't take much time because you can grasp the thing very well. But to like let me just cut that. But to like, let's say, like to express the logic. Let me just drink some water. My throat is a bit sore, and like I want to stay hydrated. But to like express that logic, you must need to know syntax. Syntax. You must know the structure in how the code is written. Let's say for suppose, and every programming languages. Wait, my mic just has some kind of issue. Papa, sound of coma. What sound of coma? Oh, okay. Now my mic is okay. So let's say for example, syntax. It's the main structure in which the code should be written, and it's very strict. And let's say for suppose I'm in Python, okay, and let me just make a new code block, and let's say for suppose I know that uh, let's say my let's assume that my logic is very good, okay. Let's use this code block only. Assume that my logic is very good. X is equal to 5, y is equal to 10. I assign them. A is equal to x multiplied by y. Perimeter is 2 multiplied by x, 2 multiplied by bracket x plus y. I understand the logic very well. That's it. But if the syntax is not good, suppose instead of writing this, I write, like uh, print area, print perimeter. Now see, you can see name error. That's the thing. No matter how good your logic is, if your syntax or how you express the code isn't written in a good manner, then your code will never run. That's why you must follow strict guideline of syntax, no matter in which programming language you are doing. So if print, I have to, in Python, if there's a print statement, I must always write in small letter P. Everything should be small letter. And if there's a variable, then I cannot enclose it in a bracket, because let's say, suppose like this. Now there won't be an error, but you see, there's only error written, but the error isn't displayed. So I have to follow strict I mean like syntax in order to like execute that logic. Now, let's just go to the slide. And readability, of course, its syntax is very easy, so it's very readable. Like, b is equal to integer input, enter a number. If this a is greater than b, then there's written like, print a is greater than b. If elif means, else if, like if this thing doesn't happen, what will be the other case? So like it's if a is smaller than b, then you should there will be a thing like, print b is greater than a. Wait, why does if have appeared? So yeah, that's the main thing. So now the main thing is, while you should all learn Python at first. So first of all, the syntax is very easy. You can like Python is such a language which helps, which is very much used in almost every domain, and it can help you understand how other programming languages work, like what is a print statement, what are functions, what is object-oriented programming. That's it. Extreme versatility in the first slide. You mean extreme versatility, this one? Extreme versatility means, it can be used almost everywhere, and it is very flexible. Like, you can use it in, like mathematical things, you can use it in finance, you can use it in data science, machine learning, AI, almost like anywhere where you want. It's not like fixed to one side, like it's not fixed to web development. You can use it like in almost everything. That's the meaning of versatility. Got it? Now, again, it is widely used in machine learning and AI. Now, you might not trust me if I say this, but let me just try asking Google this question. So, what is the most used language used language for ML? Python. See, here you can see that Python is most used programming language for machine learning and artificial intelligence. It is widely considered the industry gold standard and is preferred by 60% of the ML developers. Now the reason is very simple. Here you can see it is a rich ecosystem. So, you know, it it has many industry standard libraries like scikit-learn, TensorFlow, and PyTorch. So you might not know these at first, but you will be familiar if you like do ML or DL. And I will be soon teaching ML once I like finish the Python, and I'm hoping to finish it fast. So you'll be familiar with these libraries very soon, because other programming languages may not have these libraries which Python offers. And simplicity, I have already explained this, because it's English-like syntax and focus focus on solving complex math problems instead of fighting syntax. That's the goal thing of Python, which makes ML developers prefer Python over other programming languages. And the other thing is community support. Let me just show it. Now it's used in machine learning and AI. Now, like Python, there is also another reason why Python is used so much in machine learning and AI. So first of all, other programming languages are very much complex in terms of syntax. Like you already know that C++ is a very hard language, and assembly language is also a very hard language, like very very hard. Even I cannot understand assembly language very well. So suppose, and on the other hand, like machine learning and AI are very complicated because they include a lot of mathematical formulas, a lot of iterations, a lot of things, a lot of libraries, etc. So if you like try to mix, I mean not mix, if you try to like use machine learning with some kind of complex library, then the complexity of machine learning along with the hard syntax of the other programming languages will make the code good for production. It's not bad for production, but debugging it and understanding the code will be much much harder. And Python, due to its easy syntax, you even if you know machine learning is hard, but due to its easy syntax, you can easily use pre-built libraries to like easily debug and make machine learning models. And wait, and the other thing is wide integration with any tool. So Python has literally wide integration with any tool. Let's say for suppose if you want to make new neural networks, so you can use PyTorch. Wait, someone has joined. Let me just add him into the meeting. Okay, so let's go. So like if you want to make neural networks, then you can use PyTorch. If you want to make, let's say for example, ML models, then you can use, let's say for suppose, scikit-learn, sklearn, sklearn, scikit-learn. Sklearn is a short form of the scikit-learn. So let's say sklearn. And for example, if you want to make AI applications, then you can use LangChain. That's also a very good Python library, and it's one of my favorite libraries because it's very flexible and you can use connect any tools. And if you want to say for suppose make some kind of API. API means wait. API means application programming interface. I will be teaching you this very soon, but for now, just remember that for making API, Fast API is your golden choice. I don't use Fast API very much and I don't know much how to use it, but you know, like for any kind of making your own libraries or you know, like connections, you can use Fast API. And there are also many other tools like you know NumPy for math. That's also my favorite library, by the way. NumPy, NumPy for math, and other libraries too. I won't be like explaining much because there are many other libraries. So wait, where was I? And the other thing is the active developer community and resources. That's already explained, and also easy debugging. Because of its easy syntax, you know, like you can debug each and every line of code without worrying about the comma or the semicolon sign very much. Now let's say what are the limitations regarding Python. Now Python isn't inherently disadvantageous. That's all I want to say. You know, like every programming language has its own, you know, limitation and advantage. But the limitation regarding Python is, you know, it's case sensitive. So, you know, like let's say for suppose, let me just teach me the code. Let's say for suppose x is equal to 10, y is equal to 20. Let's make it capital Y. So now if I try to like print, yeah, exactly. Krishna, you are absolutely correct. Let me just show it once again, just for quick understanding. So if I try to like show it in like, you know, x plus y, here you can see that y is capital and here you can see y is small. There also you can like see like there's a kind of yellow color thing, like you know, y is not defined because Python by nature is case sensitive. So whichever letter is capital, you must write in capital. Whichever letter is small, you must write in small. That's the main thing of Python. You cannot like, you know, switch between capital and small letters without, actively knowing the syntax. So even if I try to print, that won't be possible because y is not defined, and that's the main thing why Python is case sensitive. And another instance why Python is case sensitive is exactly the thing which you told Krishna in the comments, not comments, messages. So you are absolutely right. And it's slow. Now in the second slide, I have told you that low level languages are typically fast, and because they can interact directly with your hardware. The syntax may be very confusing, you might not understand this, but this type of syntax is the one which the computer likes to use and understand. Like it can be understood in like very less time, in a matter of seconds, by the computer. But to understand this thing, it must need to like strip these things into like basic blocks in order to execute it. So it will take a lot of time. The high level languages, and I also forgot to explain one thing. High level languages usually take more time to execute than low level languages, if we are talking about time. Got it? That's the main thing. Wait, let me encircle it. High level languages take more time to like execute than low level languages. And Python is a very high level language because of its close to English syntax. So of course it will naturally take time to like execute, and it requires proper hardware specification for AI and machine learning tasks. So like AI, like basic Python, you can run on almost any kind of device. But when it, but this is a very specific point. Like AI and machine learning tasks usually require a specific set of hardware to like execute properly, because like, let me just ask Google so you can better understand it. Why ha- hard hardware is required in AI ML with Python? See, now the main thing which wait the main thing which why I'm stressing on this point is because you need a proper GPU or graphics driver in order to like properly execute the AI/ML tasks which are done in Python. Let's say for suppose you are you have a very low end PC. You can run normal Python in it, no problem. If but the main problem comes with AI and ML libraries which have a lot of computational work. And large computation means that it needs better graphic card specifications. So there is a specific operation which I call it matrix multiplication. Matrix multiplication. If you have like done math in higher standards, then you must be familiar with this, if I'm not wrong. So let me just ask a question to Google. Does is matrix multiplication computationally expensive? And the answer is yes. See, yes, matrix multiplication is highly computationally expensive because for two answers, just ignore these things. And here it is written that for AI and graphics rendering, rely heavy on specialized processors like GPUs. That's because matrix multiplications are widely used in machine learning and AI. Like the entire AI is nothing but matrix multiplication function. Just understand this. So if your specifications of device is not like up to the standard of the task which you are using, then the matrix multiplication might run off your GPU, and it would take a lot of time to like execute. That's why wait. That's why where was I? Wait, let me just back it. That's why it's saying that training model requires millions of complex matrix calculations. Python handles the logic, but specialized hardware like GPUs does the heavy lifting, like thousands of calculations simultaneously. That's the thing. Now, and you might just, if you have done coding a bit before, then you might have known that, like, you might not know right now, but let me just tell you, the there's a reason why coding in Google Colab is much more faster than coding on VS Code or so. I mean, in the case of Python, because Google Colab uses doesn't use your hardware, but uses the cloud hardware. It uses the GPU from the Google Cloud Center. So the GPUs running Google Cloud Center will run your code in a much faster rate. But in VS Code, you are using your local device system components to like run your code. So that would take a larger time. I mean a longer time, sorry. And poorly designed code may not be able to scale to massive datasets for users. That's a very important point because you know there's a lot of saying that Python is not good for production, and I highly believe in that because Python requires a very good amount, I mean, like a very well designed code in order to execute to larger extents. Like it can perform very well in small scale, but to scale on massive data sets and users, it must need to like have some specifications. Now, now the main building blocks of Python, I mean, like the main building blocks of Python are variable, function, and statements. Just try to understand this. That means that Python, if you like strip of the functions, like for example, not strip of the functions, like if you strip of the libraries, just forget the libraries at all. Just think of Python as basic structure of syntax. Then everything will be down to variables, functions, and statements. That's it. So let's say, let me just write a small program. Uh, let's define. Uh, you all guys can also like write this function because it's up to you. Now turn. Now let's say print break, bracket. Now you will be seeing that this thing. Now wait, someone has just joined the session. Okay. So this is a function. Define this thing. I won't be teaching it much, but you know, like everything in Python, I won't go much here. Let me just start from here. So whatever you are seeing here is a variable. Variable is nothing but something that holds a data. So in machine learning and other kind of thing, you must always need a kind of data which you are working on. And normally data doesn't exist independently. It must be in the form of a kind of variable, like let's suppose z is equal to like this. This is a data, this is a data, this is a data. So variables are nothing but the wait, my mic was just disconnected. Oh, sound mana hai mana? Okay, my mic has just reconnected again, and so variables are nothing but places, placeholders for storing. Wait, let me just minimize the screen. Data. That's the smallest definition of variable. Not the smallest, I mean the simplest definition of variable. That's it. If you can understand this concept well, your entire thing of machine learning as well as programming will be clear. Like whenever you are, like, in almost all cases, let it be C++, Python, or any kind of programming language, you will be always working with variables. And in most of the cases, you assign a variable. That means, like, x is equal to 10. Or x could be also like, if you are working with libraries, it can be like, x is equal to, let's say, for example, numpy dot array. Why am I typing here, by the way? I could also type here, like, x is equal to numpy dot array bracket this is. That's also a variable because x is holding a kind of feature which this thing cannot independently exist without. So basically, x is the placeholder for this kind of data. Now this thing is like here because I did this thing is like, having squiggly lines because I did not define the numpy this thing. Doesn't matter, by the way. I'm just teaching, Python, like the basics of Python. That's the thing. Now in Python, you will be constantly switching between variables. Now let me just dive deep into like variables, statements and functions. I will teach you a bit later. So variables have a subset which is called data types. So data types is the thing in which the data, like, behaves and functions with the computer or a program in which you're working. So let's say, for suppose, uh, I just forgot to like show you all. Wait, let me just write here only. Okay, like for example, and always try to remember that there are four data types primarily in Python. I don't know about the other programming languages much, but in Python there are four data types in usual. That is strings, booleans, floats, and integers. So let's say, for suppose, string is equal to, there's a reason why I did not like write the float in small letters, because float is a kind of function, but I just want to show you. So to assign it a variable, I will like write in capital letter F. So float, let's say for example 3 point equal to 3. That's all correct. So now you can see that string is a hello world, boolean is a float. I mean, like, boolean is true, float is 3.2, integer is 23. So what I'm trying to show you is that there are different types in which data can be stored. It can be stored in textual form, which is often called a string, in this form, which is called boolean. I will be explaining this a bit later, by the way. Just remember that boolean is either true or false. That's it. That's it. That's the entire thing of boolean. Boolean, and if you try to write the boolean in, like, say for example, small letter, then it will be totally wrong. The Python interpreter won't understand it at all. At all. You must write the booleans in capital. The first letter of the boolean should always be in capital. And wait, let me just show you. Primarily, booleans are of two types, that is true and false. So that's a special type of data type because in booleans you don't try to like show data, you try to like show the either cases, which is either true or false, which is either correct or right. It doesn't have any kind of special mathematical or numerical property, but it shows try like some kind of categorical output that is either true or false. And always remember that the fir- the first letter of boolean is always capital. It's always true or false, nothing else. I will be working on it soon, by the way. And float are nothing but decimal points. Let's say, for example, 3.2. That's a float, and again, like 2.30, 2.33, sorry, 333. That's also float. 0.29. That's also float. 100.21. That's also float. Any kind of data that has a kind of decimal point in it, that will always be a float. Always try to understand this. And now that might sound very, like that might sound very small because who cares about decimal points now? But you will soon understand it when you will be using machine learning, because in machine learning the weights are always in decimals. Because if you try to like let me just remove this. Because if you try to like wait, I by mistakenly have like exited this thing. So like if you try to like put the weights in, let's say for example whole numbers, like starting from 0 1 to any kind of number, let's say for example n, then the machine learning model won't learn at all, because typically machine learning models have the tendency to like take small steps, not in whole numbers but in decimal points. So on top of that, if you like try to use the whole numbers, then your entire machine learning model will give wrong results. You might not understand my what I'm saying right now because it's a bit technical. I hope you can understand it in the simplest way possible. And the but if I use like floats, that's a integer, by the way, integer. That can be also negative one, by the way. I forgot to mention it. And if you try to like, if the weights in the machine learning model are set up in floats, like let's say 1.2, 0.9, or any kind of thing to the power, not to the power, like sorry, like 2n, n point m, then the machine learning model will actually learn from the data, because it can identify the smallest point error which occurs mathematically inside it, which do not require like reducing an entire whole number, but like subtracting a point, like say for example 0.5, etc. in it. So that's where floats come pretty handful and useful. Now in basic Python, floats are not very much important, but when you will be using machine learning and deep learning, then they will be very crucial. And now integers. Integers are very simple. You just like -2, -3, 1, and then like 300 or any number to n. That is an integer. Integer are any kind of number which does not have any kind of point in it. That's the entire definition of integers. That's very simple. Now I will be showing you how you can write in code. Now I will not start from this kind of thing. I will like start from down to up. Okay, from integer to strings. So let's say for example x is equal to 2, y is equal to 2. So which one of them do you think is an integer? X is equal to 2 or y is equal to like inverted column comma 2? which one is actually an integer. Mathematically both are correct, but according to the syntax of Python, which is actually an integer? If you can you can write in messages or comment whatever. Exactly, you are correct, because integers in Python must always be written like this independently. If you write like, sorry, if you write like this, then the thing is that, yeah, it will be counted like a string. Exactly. So integers must always be written in independently without any kind of symbol, other symbols with it. It must not even have a kind of point in it, or else it will become a kind of, like float. That's the entire point of integers. And floats are also similar to integers. So, like Python 3, see in in the bottom right corner you can see there's Python 3. So Python 3 like generalizes the use of integers and floats. Like, let me just show you. Integer and Python 2, Python 3. Let me just show you one thing. Yeah, here. So try to look at this thing. This thing 7 by 2 is equal to 3. In Python 2, which is not used today, you can see that if I divide any kind of integer by any other integer, but the answer is mathematically in a kind of float or a decimal point, then Python 2 did not interpret this and used to like round off to the nearest decimal points. But however, in Python 3 and above, you can see that in the first two data, like 7 and 2, are integers, but the result float. That's the thing, because Python 2 used to standardize the, not standardized, like it used to like you use a fixed set of algorithm and used to reject like unwanted mathematical outputs. But however, Python 3 like incorporate math with and tries to generalize the use of integers and floats. So, like integers and floats are almost used interchangeably. Now, let's say for suppose x is equal to 223, y is equal to 3.2. Now, in Python 3, these things will be mathematically computed in whatever result the calculator should be doing in a normal math. So let's say for suppose print, sorry. Now, as you can see, it's 7.1875. Let's say for suppose 2, then it's 11.5. So now in normal, in like in Python 3, the integers and floats are almost used interchangeably. There are no differences. But in like deep learning, you must like know how to differentiate floats and when to differentiate integers. Okay, got it. I hope you can understand. Like dropping a comment or message would be like considerable. You all can message if you like did not understand something, and I will be ready to explain it again. I guess everyone has understood. Now we will hop to strings. So now here float and integers, I guess you understood. In summary, like float and integer are data types which have numerical values. And but the difference between float and integer is that float are basically decimal points. So floats are shown in decimals, but integers are in do not like contain generally do not contain any kind of decimal points in it. That's it. But the thing is that functionally both are almost the same, because uh, in float also you must write it independently. That means like you cannot enclose it in a bracket, you cannot like use inverted commas in the float as well as integers. So you have to both you have to address both float. No, you did not like miss something important. I was just explaining a bit of floats and integers. So like float, you must like, even though like you are not you, you if you are like you know as you gain experience in programming, you will be addressing integers and floats in almost the same way. Like you will like not try to differentiate each and every step. That's one thing. Both do not require any kind of external things, and both can be used almost like interchangeably. That's the main thing. And now we will head to booleans. So I guess I've explained booleans. So I will just again try to explain it like booleans, or the short form is bool, BOOL. That means that they are only of two types. That's the first type, that's the second type. That's true and false. That's it. And always remember that the first letter, wait, sorry. So the first letter of, so the first letter of booleans is always capital, is always capital. Always try to remember this. If you write in kind of like small letter, then it will be considered an error. That's the main thing. Now booleans are very simple, but they are required in like very specific cases where there are a bit of categorical outputs, which I've explained a few minutes ago. Now we will be soon heading into strings. Strings are anything other than you know strings. The short form is str, by the way. Strings are anything except integers, booleans, or floats. String by default do not have any kind of like mm, functionality by itself, because they are usually most in designing kind of like they are used in fancy kind of things like web pages, or naming things, or like addressing the columns, or etc. They do not hold any kind of mathematical things. But strings have a mathematical property which is called you know embeddings. Embeddings. You might not understand this, but for now just ignore this. So I'm just cutting it. Ignore embeddings for now. I will teach you like a bit after some time. But for now, just keep in mind that strings do not have any kind of mathematical function or value. They are just text. And always remember that strings can contain numbers. Like for example, I don't want to like, let me just show you in code only. That will be a better option. So let's say for suppose text is equal to 9. So I will be just showing the actual reason why strings don't have any kind of mathematical function. Let's say for example, Yeah, you are exactly right. Anything under quotation marks are basically strings. So now you might be thinking, will it be used for mathematical function because it's 10? But I have explained earlier that integers or floats which have a kind of mathematical properties are do not are and shouldn't be enclosed in any kind of symbols like thing. So if I like keep it like this, then it's an integer. But if I like keep it like this, then it's not an integer anymore. It's a string. Even if it looks like a number, even if it can perform mathematical function out with means hypothetically I'm saying that even if it can like perform mathematical function on paper, but on Python program it cannot do at all. Sorry, that should that should be x, and let's suppose y is equal to 2. Now let us try adding those numbers. But before I try to like proceed further, I just want to like ask you all whether you all are coding alongside me or not. You all can just like say yes, no, or any other thing in the chat, because yeah, it's understandable, by the way. Krishna, I was saying that I was asking that whether all of you are coding alongside what I'm teaching or not. Even if you are not coding, I would like to know. That's great to hear. That's great to hear, Jody Michael, and I like your honesty, Mo Vasi Khan. No issue, by the way. You can take notes or something, and you can like understand anything. You can like try to understand by your own. That's not an issue at all. At least you are attending the lecture, so I hope you understand what am I saying. Jody Michael, appreciate that, man. You are coding in VS Code, right? Not an issue, by the way, because VS Code and what Google and I'm using Google Colab, they are both practically the same. Okay, Krishna, understood. Anyways, I would like to thank you for like at least attending my lecture. Yeah, Mohasi Khan, you are right, you are right. Anyways, I will like recap about the things in the next session. Yeah. Thanks, man. I appreciate that very much, from my inside, I'm saying. I hope you all can understand. Ah, great to hear. So let's go. So we were in the topic of addition of strings. Wait, what did you say? Hazaima Anik can share notebook links with us. I will try to share, but it does not have any kind of thing because I'm repeatedly cutting the code and again making it. So even if I share, that won't be much of a benefit. So let's go. So x is equal to like let's say or suppose that's a string, okay, because it's enclosed within an inverted comma, and y is equal to this. Now, as I told in the lecture that I mean this today's lecture that strings do not have any kind of mathematical properties. So Now you must be now you must think like, what if we can add these two x and y's? Let's try to add them. Uh, I want print x plus y. Now let's see the magic. Wait a minute, what? How did it happen? I'm by myself confused. I'm literally confused. Oh, wait, let me just check. Huh? Yeah, yeah, I just forgot. I just forgot it. Yeah, yeah. So, like, they are not mathematically added, but yeah, 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 exactly, exactly. I just got confused. I have been like playing too much with machine learning, so yeah. Thank, thanks for the comment by the way, Krishna. I appreciate it. Hazaima Anik, so we can be a code right? No happen. Yeah, yeah, sure. I will try my best to create a note. No issue. So as you can see that those kind of things are not mathematically computed. They are computed in a textual manner. Anyways, Krishna, I would like thank you for supporting this kind of lecture because I also made a small mistake of like, you know, anyways, no issue. So see, the 10 and 24 are not mathematically added. They are combined. They are not mathematically added. They are textually combined. So if I do it like this and if I do it like this, you can see it's not returning 34. It's returning 1024 because two two strings when added join together. Always remember this. Two strings, two or more strings added always joins slash combine together. Now again, if I try to like, do like this, then check the magic. Here, you can see, right, in output it's showing like, one, there's a space between them. That's the main thing. Because strings do not care about the mathematical properties of whatever number you are writing or not. They just care how much space you have left, what text is there, that much. So, mm, so the plus operator in strings does not like mathematically add two things but like combines or joins two different strings. That's it. Now now let us try this thing. Now you will be seeing, see, as I've told that strings don't have any kind of mathematical properties. So x is equal to string 10 and y is equal to integer 2. So if I try to add them, you can see that in the error it's showing like two or more strings always. No, that's my comment by the way. Forget it. Like see, you can only concatenate string, not int to string. That means that concatenation means this thing. That's the entire definition of concatenation. If you like in data science or machine learning, you'll be often use like faced with this word concatenation, but that basically means that joining or combining two different strings. So here it is written that can only concatenate string, not integer to string. So it's saying that integer and strings cannot be joined together or added together at all, even if they're written in numbers. For that to happen, either x or any kind of string has to be in the form of integer, I mean the numerical integer or any kind of float, whatever numerical value, and y has to be a kind of integer 2, or in another kind of case, x must be a string and y also has to be a string. Yeah, 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 exactly, exactly. You are correct, Krishna. Thanks for supporting the chat, by the way. It's a great help. I genuinely like I genuinely respect your like support. So that's the kind of thing. So now let's say for suppose now now let's by the way, sorry, like I have a very bad habit of like cutting the code blocks in Jupyter notebooks or Google Colab. So I hope you don't mind. So now let's see adding to different different text concatenation. So let's say for suppose hello is equal to hey there, what's sorry, what's your name? Response is equal to hmm. Now see hello, hey there, what's your name? Response, my name is CJ. And let's say for suppose uh, he said, and I'm just leaving a bracket, not bracket, I'm just leaving a empty space so that there is a space between words and they do not look joined together. And let's say for example I said my name is now like just try to uh, some of you might be using like a kind of Python interpreter or might be coding parallelly to the lecture, so just try to like add those kind of things. So adding, just try to add them once. Let's go. And here you can see, hey there, what's your name? He said, and I said, my name is CJ. You can see that there is a kind of space here, and like if I try to like remove that space, then see, he said, and these two are joined. So by definition, strings have a concatenation or joining property. Most people don't try to like show this kind of thing. Most like if you have watched Python tutorials in YouTube, then most people like do not show this step or do not show this theory that string have a concatenation property. But I'm showing you because I want to teach you very properly, because this thing, you know this specific word, the concatenation, this kind of word you will often find in machine learning, data science, or any kind of data related thing. And and here you won't be dealing with numbers at all. Like even if it's number, it will be like enclosed within a bracket. That is a string number. That is a 5. That's a string number. Okay, you're dealing with this kind of number while doing concatenation, but never integers. Always try to remember that. And concatenation, now you won't be using it, but I'll be showing you how. For now, just remember that string have a concatenation or joining property. Try to note it because it's a very important topic that most tutorials don't want to show you or like forget to show you. Am I right, Krishna? I just want like yes or no. Yeah, yeah, thanks for the reply. I like it. That's the main thing. Remember this thing. And also one more thing I want to like stress upon is that thing is not like plus in string. It's I'm not using any kind of function. I'm just trying to like show it in a diagrammatically way. It's like let's say suppose 2 plus 2 4. Oh, sorry, my fault. That's a string. Okay. Yeah, exactly, Krishna, you are right. I'm just trying to show in a schematic diagram way. 22 and plus in. Sorry. Yeah, it's correct. Remember this entire thing in your Python journey. You will be needing this, and it's very important topic. That means, plus in the case of string, even if the string has any kind of number or any kind of text, then it will join the two separate strings. Always try to remember this thing. But however, the plus operator in integer or any kind of float or in any kind of mathematical data type, it will always be adding the data, as you can see. So basically what I'm trying to say is that plus in string means concatenation, and plus in integer means addition. Most Python tutorials forget to show you, but always remember this thing. Plus in strings means concatenations or joining two separate strings. However, plus in integer or float means that you are adding two mathematical numbers. Always try to remember this, because now it might not be of much use in this boot camp because I won't be using this much. But when you are dealing with huge data and like changing files or like adding file paths to some kind of you know program or something, then you will often use this thing, and you need to be cautious about the strings and integers. So I'm just trying to explain it on advance. I hope you all can understand this. I just appreciate if you all can like give a positive reply on a message. Thanks, Krishna. I really appreciate your active participation. That's the main thing. Okay, so now I hope we have covered the basic of string, booleans, floats, and integers. If if there's any kind of doubt or any kind of thing which you need to know, you can feel free to ask me, and I will be ready to answer and show it to you. If you have any kind of doubt, like feel free to like text, not text, like message here, right here only. I guess no one has any kind of doubt. I hope you all have understood what I have like tried my best to explain today. Okay, and I hope that you all will try to like make some kind of uh, like try to make programs around it, like around this topic. So before I end this lecture or this session, I will just give you some homework. You don't need to show me necessarily. You can like try and experiment with your own. Let's say I'm giving you one homework. Uh, for example. And yeah, yeah, I also forgot to like show this thing, this input. I won't be showing it today because it's almost time. However, I will be definitely showing it to you tomorrow. I hope you all will like, I hope you all are comfortable with what I have taught today. Good. And I'm just giving a last homework and then I will cut the lecture. I will end the lecture. Try to like do this two kind of program. I hope you all will be doing this program. I will also be sharing it. Yeah, yeah, sure, sure, sure. I will definitely be sharing it. Sure, all sure. Welcome, man. Before you leave the call, I just like you can like practice these two exercises. Like write a program to input this thing and write a program where this are two different strings and try to concatenate them. I hope you all who are attending the lecture will try to like you like learn or like revise and try to like write a program around these two questions. For now, I guess you all can leave. Wait, wait, wait. What did you say, Krishna? I'm just a normal school student. I'm just a school student, and for a living, what do I do? I just like manage some technical business, and I try to like learn machine learning and manage my studies. That's all. Since my summer vacation has started, so I'm like thinking of like spending my free time like teaching people coding. Like what's like that would be a very great job. I would like to know about you. Like, are you from school or college? Yeah, yeah, Krishna. Oh, that's great. Great to hear, by the way. Hope you like do your boards well, and I also hope that you score more than 95% on boards. Study well, okay? Yeah. So I guess now I'm I will like now I'm stopping my presentation. Yeah, possible do it with IP. By IP, do you mean informatic practices? Because I am also from India. IP. Yeah, yeah, sure. IP is exactly similar to what I am teaching. Almost similar, but IP books don't cover much topics, but I'm trying to explain deeply on what I am like showing you all today. Anyways, goodbye. It was a nice session with you, and I hope you all attend tomorrow's session too, which is also at the same time. And for now, I guess, bye. You all can leave now. Goodbye.